Today we will be taking a journey down a very interesting programming question where we'll be tackling it from multiple perspectives. We'll start with a solution that could be something written by a beginner, we'll move to a more intermediate piece of code, and then finally we'll wrap up with a discussion about what an advanced Python user might write. And in order to do all of that, I'll start by sharing my screen. So behind me you'll see my screen, and I'll hide here in the corner. This just doesn't make sense. Now, let's go ahead and take a look. We have 3 colleagues who are going to eat at a fancy restaurant. They decide to share the cost of the meal evenly, also known as going Dutch. Now, let's take a look at how we might actually compute this using Python. Well, we'll have our bill, we'll have our guests, and you can see here that everything looks correct on the superficial level. But if in fact you add up each of these payments that each of our guests is actually creating, you'll notice that we're not paying $1,234. We're actually ending up paying $1,233.99. The restaurant needs that extra 1 cent. And in fact, if they don't get that 1 cent, they'll be quite upset. So our job is to fix the above program so the restaurant gets all the money that is owed. And, well, we might write our original program and make it better, but what good is a program if we have not tested it? So we'll also write a test with PyTest and hypothesis to ensure that the code that we've written is correct. Now, as a beginner, I can say that the easiest solution to this problem is to use integer arithmetic and the divmod built-in function in Python. You can see here that I'm no longer using a floating point value to represent my actual monetary value here. Instead, I'm using an integer. And that's because we know that there are some issues with floating point arithmetic when it comes to rounding. And instead of working with dollars, we'll instead work in cents or work in pennies because these are discrete values that we want to be working with. Now, with our discrete values or our pennies, all we really need to do here is calculate the divmod of our bill. And as a reminder, our divmod is simply the value that is still left remaining after we make equal payments. And in fact, if you look at this code and you're unsure, I haven't seen divmod in Python before, it is a built-in. This is the exact same as performing a floor division, which is signified by our double forward slash operator, together with our modulo, which is our percent operator in Python. And so instead of using divmod, I could also calculate our floor division and get my remainder using percent. And in this case, we see that everyone pays the same amount, but then the remainder, we're going to say that that is Alice. Alice is going to foot the remainder for us. Now, if we wanted to test this code with PyTest, well, we need to put it into a function. And so if all I do is take the code we've already written and indent it, put it inside of a function and give it some inputs, we see that I can write the same code and I can run it and we get the exact same output. We see that everyone pays the same amount, but then Alice at the end pays that 1 cent extra. But it's reality, it's often difficult, or I will say it is difficult or clumsy to test output printed to the screen. Functions that are printing are hard to test. So instead of just printing values, we need to return something. And I think a good choice for this problem is a dictionary that maps each guest to their payment. And so instead of simply printing each guest and the amount that they're going to pay to the screen, I can work with a dictionary Python object. So here you can see that I'm mapping each guest to how much they pay. And then I'm selecting out Alice to say, well, Alice is going to pay the remainder, and I return that dictionary. Then on the extents, or the most exterior part of my program, I can actually use that dictionary, and I can then iterate over it and print out my message. My function should not have the job of performing my printing or my logging. Instead, I'm going to actually leverage the most internal portions of my program to simply work with data structures and return them. Now, when I run this code, we see that the output is very similar to what I had before, but in this case, we've simply factored in that Alice is paying in that extra penny. But I will say this, I'll say that this code is still wrong. And the reason we say it's wrong, well, it's really honestly unfair that Alice has to pay the extra penny every single time we go out. And what if Alice isn't even at dinner? For example, if I remove Alice completely and rerun this code, we get a key error here, meaning that we have embedded a large assumption into our function, and that is that Alice will always be present. So, how else might we approach this problem? Well, our beginning programmer might say, okay, if I can't say or assume that Alice will be there every single time, instead, I'm going to make a random choice about which guest is going to have to pay that extra penny. And I'll do this by using my random choice function from the random module. And you can see, instead of hard coding Alice as my dictionary lookup, I'm simply taking a random choice of all of my guests. Now, when I run this code the exact same way, we see that different people will be stuck with that extra penny. For example, right now, Charlie has that extra penny, and when I rerun it, it's Alice. If I run it again, we see that Bob has to owe that extra cent. And so this is nice and fair. Depending on which time we're going out to dinner, somebody else is going to have to pay that extra amount if the bill doesn't split evenly. So if I wanted to test this, well, a beginner might write a smoke test using PyTest and might not be ready to use a tool like Hypothesis just yet. And so the simplest test we could write was that smoke test, meaning I have some known inputs and I can map that or align that against some expected outputs. For example, if I write a function called test_split_bill, and I take a bill of a known amount and guess of a known length or guess of a known number, I can calculate their payments, and then I can assert that each person pays a specific amount. In this case, I know that if I take, Python here, if I take 123 and divide it by 3, each person should be paying $41, or in this case, 4,100 cents. So I can map that to my expected output and I can run my test. Then I can take the case where we pay an uneven amount and I can say that Alice is going to pay the extra amount. And when I run my tests, oh no, it seems like this test doesn't work. Maybe let's run it again. You know what? I think if I run it a third time, you can see our test pass. Okay, so our test passed 1 out of 3 times with absolutely no changes to the code. If that feels okay, I would urge you to think about what's called the determinism of your functions or of your code. The reason that our tests pass sometimes but not other times when we make 0 changes to our code is because our function or our split bill function is undeterministic. The nice thing is we can make it deterministic, and all that determinism is that each time I run this function, I get a different output despite having no changes in my inputs. So in order to make our function deterministic, I can actually pass in a random state from the exterior or external to my function. And so I don't need to write too much new code for this. In fact, I can actually just have my function take or accept a random state variable, and I can instantiate that random number generator if I didn't pass one in. This lets my code still be completely backwards compatible with all of the code that I've previously written, but the nice thing is I can force my function to have the same outputs by implementing my own random number generator, or I should say instantiating my own random number generator. So now that our function is deterministic, we can test this. With our deterministic output, or input, I should say, you can see here, all I've done is specify my random state, and I can run this test an infinite number of times, and I will end up passing this test every single time, even in the case where we know the bill in advance and we know it's split unevenly, all I need to do is check, well, who got the extra penny when the random state was based off of or seated on the value 0. I can see that's Bob, and then I can just kind of hard code this as an oracular output, meaning I had some insight into what the output was going to be in advance before I called this function. So with this testing approach, I can see that in the case where my bill is split evenly, right, we meet our assumptions, and even in the case where my bill is split unevenly, we can see that we meet all of my expectations. This is how a beginner might write this code. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.